continuation of the last lesson assignments. Now let somebody stand up and read the question for us. Assignment question. Want to read it? Okay.
An aeroplane flies from a town B
40 degree.
40 degree north.
B 40 degree north.
38 degree east.
I'm coming. 38 degree east. Okay.
To another town Q.
To another town Q.
40 degree north.
40 degree north.
22 degree west.
22 degree west.
It later flies to a third town T.
A third town T.
28 degree north.
28 degree north.
22 degree west.
22 degree west.
Calculate A. The shorter distance between P and Q along the parallel of latitude.
Okay, hold on. Now sit down. Now let me interpret what we have on the board. And T. Now, let me start by drawing the globe. We have this globe. Now this is the globe. We have this as polar axis. We have this as equator. This is north, south, 0 degree east, and we have 0 degree west. Now, according to this point, 40 degree north. This is 40 degree north, 40 degree north, 38 degree east. This is east, this side. 38 degree east. And there is a point of intersection. This is a latitude, this is a longitude, this is the point of intersection, and it is P. Then Q, 40 degree north again. You don't need to draw another one. 22 degree west. This is west. 22 degree west. This is a latitude and this is a longitude. This is the point of intersection, and this point is what? Q. Then this latitude is a small circle. The center of this latitude is here. Join this to this and to P. Then, okay. Now then, the other point, T, 28 degree north. North is under that of 48 because the highest one here is 90 degree. So now that that one is 28, you can have it under this. 28 degree north. And on the same longitude, 22 degree west. This is 22 degree west. This is the point of intersection, and this point is called T. Now, this is a longitude, and the center of this longitude is the center of the Earth. You can join T to the center of the Earth, and also Q. So this is the diagram. Now, from the first question where we are asked to find the shorter distance between P and Q, Abi. So look at that PQ. Distance PQ. Distance PQ equals to theta over 360 times 2 pi. Is it small r or big R? Small r, because the two of them are on the same latitude. And that latitude is a small circle. But that small r can be written as 2 pi big R cos alpha. Now let us get the angular difference. Now you can place your fingers on P and Q and trace it down. These are the two values one can use now to get the angular difference. We have 22 west and we have 28 east. Are we going to add or subtract to get the angular difference? Add. So it means that angular difference is 22 plus 28, and that is what? Is it 38 that we have?
Yes.
This is 38?
Yes.
Ah, okay, it's 38. Sorry. So 22 plus 38, and that is what? 60. So angular difference is 60. So if angular difference is 60, what is the common latitude? 40. Our common latitude is 40. Alpha equals to 40 degrees. So we can now come back to this formula and do the substitution. What is theta? 60 over 360 times 2 times. What is pi in the question? 22 over 7. What is R? 6,400. And what is alpha? 40. Now we have the product of 360 and 7 is 2520. Now we have 60 times 2 times 22 times 6,400 times what is cos 40? Multiply all the numerators together, what do we have? 129 336. all over 25, 20. What do we have? 5, 3, 5. No point. 84 kilometer. Please, do you have degree of accuracy in that question? What is that? So 3 significant figures. 1, 2, 3. What do you think will be the answer? 5140 kilometers. That is the shorter distance between P and Q. Now, after that, the next question, please.
The shorter distance between Q and T along the line of longitude.
Along the line of longitude. Distance QT. I think this one is question A, right?
Yes.
Okay, why this one is question B? Distance QT, that is theta over 360 times 2 pi. Is this smaller or bigger? Bigger, because both Q and T are on the same meridian. Meridian is a great circle. Now let us get the angular difference. Angular difference is this. We are using these two. Okay, and we have the 2 points on the same pole. What do you think will be the angular difference? Is it subtraction or addition? 40 minus 28, and that is 12. There is no alpha. Now we have 12 all over 360 times 2 times 22 over 7 times 6,400. The product of 360 and 7 is 2520. What is 12 times 2 times 22 times 6,400? 379 3379 200. Abi? Okay, divided by 2520. 1341 1395 kilometer. Do we have degree of accuracy for that one too? Yes. What is that? 1, 2, 3. What is the answer now? 13400. 1, 2, 3. 1, 2, 3, 0. 40. 1340 kilometer. 1,340 kilometer. Is that taking? Okay. Now what's the last question? See.
The average speed at which the aeroplane flies from P to T via Q if the journey takes 2 hours.
If the journey takes 2 hours, Abi?
Yeah.
2 hours.
Yeah.
Okay? Distance equals to speed times time. Now the total distance here is going to be distance of this one. I can use the approximated value. I can use 5135.84 plus this one too is 1340.95 is equals to what we are looking for is average speed, right?
Yes.
Okay, and what is the time taking? What is the time? 2 hours. Okay? Is it 2 hours?
Yes.
Okay, what is the sum of this? 647.79 equals to S times 2. Now 6476.79 all over 2 is equals to S. Divide. 3295 kilometer per hour equals to speed. Now what is the, do we have degree of accuracy in that question? What is that? 3240 kilometer per hour equals to speed. Is that taken? So that is how to go about that assignment. But I want to finish this latitude and longitude today, and the last aspect of it is great circle route. 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 In geometry of the Earth, the equator and the meridians of longitude are are the most common great circles? Is that taken? Let me take that again. In geometry of the earth, the equator and the meridian of longitude are the most common great circles. Full stop. However, there is an infinite numbers of great circles. However, there is an infinite numbers of great circles on the surface. However, there is an infinite numbers of great circles on the surface of a sphere. Now you draw this diagram. You draw this diagram. Now quickly draw the diagram. Or you can leave the space for that and continue with this note. The diagram above, please you can leave the space for the diagram and draw that later. The diagram above is a sketch. The diagram above is a sketch showing point A and B. The diagram above is a sketch showing point A and B on both a circle of latitude, center C, and on a gray circle, center O. And on a gray circle, center O, full stop. Indeed, any 2 points on the surface of the earth, lie on a gray circle. Lie on a gray circle. Now the shortest distance between any 2 points, the shortest distance between any 2 points on the Earth's surface, the shortest distance between any 2 points on the Earth's surface is along the great circle that connects them. Now, let me explain this. You all know that the only latitude that is a great circle is equator. Okay, and apart from that equator, every longitude is a great circle. But whenever you have 2 points, on the globe, you can find the shortest distance of the 2 points, and that is what is called great circle route. Now look at the diagram that we have here. When you have A, look at this BA or AB. This is distance along the parallel of latitude by using this angle C, which is the angular difference. Are you with me now? Angle C is the angular difference. But the moment you now use this angle O as theta, that is the shortest distance, and that is the great circle route. Because this one is going to give you bigger, this is bigger, this is what? Bigger. But this one is smaller, this is smaller. This one is shorter distance. Why this one, if you use this theta as angular difference, that is what is called shortest distance. Is that taken? Despite the fact that the 2 points lie on the parallel of latitude, we can still find their shortest distance, and that is what is called great circle route. Is that taken? Okay, now let's try this example. A and B are points on the parallel of latitude. A and B are points on the parallel of latitude. 58.4 degree north. 58.4 degree north. 58.4 degree north. Comma. Their longitudes being BEING 148 degree west, 148 degree west, and 32 degree east, and 32 degree east, respectively. Full stop. What is their distance apart? A, along the parallel of latitude. B, along a great circle. Now let me quickly interpret this question. Now this is the globe. Now we have these as polar axis, equator, north, south, 0 degree east, 0 degree west. Now, what is the latitude that we have in the question? 58.4, so Abi? So, north, Abi? So, 58.4 degree north. 58.4 degree north. Now, the first longitude is 148 degree west. 148 degree west. And the point is A, Abi? This is point A. We have latitude 58.4, we have longitude 148. This is point A. Then the other one is 32. 32 degree east, Abi? 32 degree east. And where is the point of intersection? Here, Abi? No. I don't want to take this as point of intersection. Why? You can see that angular difference is 180. So that line, if you have, look at this one. This is radius, this is radius. But the moment the angular difference is 180, that line has become what? Diameter. So I'm going to have it here. This is point B. And this is what we are going to have. we are going to have a diameter. Diameter is a chord that passes through the center of the head. So I don't want to put B here. Is that taken? Okay. So if B is here and A is here, we can find the distance along the parallel of latitude. Is that not the first question? Okay, let's find that. Question A. Distance AB along the parallel of latitude. Parallel of latitude. Latitude is equals to theta over 360 times 2 pi small r. I believe you all know the reason why it is small r there.
Yes.
Why? What is the reason? It's a small circle. And what will be the angular difference? Angular difference equals to 148 west and 32 east. Are we going to add or subtract? We are going to do what? Add. So 148 degree plus 32 is equals to what? 180. So I will now come here and write, let me change this small r to big R cos alpha b. 360 times 2 pi big R cos alpha. Now, where the angular difference is now 180 over 360 times 2 times, what is pi in that question? You are not given. But okay, if you are not given that pi, then it's 20 over 7 times 6,400 times cos alpha is what? 58.4 degrees. Now we have 360 times 7 is 2520. 180 times 2 times 22 times 6,400 times what is cos 58.4? 0.5239. 39 what?
398.
That's 40 then. 40, right? Okay. Multiply all the numerators together and divide by 2520. 10,500.660 kilometer. That is 10,539.6 kilometer. That is the distance along the parallel of latitude. But after that, the second question is to find the distance along the great circle. Although both A and B are on the parallel of latitude, but we can still find their shortest distance. If I want to find their shortest distance, it's going to be easy because the angular difference is 180. I'm still going to give you another example where the angular difference is less than 180. If the angular difference is less, you have a question? Is point? Is it 0.8?
571.
0.88. 5, let's say 0.89 kilometer. 0.89 kilometer. Okay? Now what I'm saying here is that if the angular difference is not 180, the way we are going to find the shortest distance will be different from this one. Now that the angular difference is 180, this is the center of the earth. Now, that's why this thing is called parallel of latitude. They are parallel. There's nothing like parallel of longitude. What we have is line of longitude or parallel of latitude. As this A is here now, image of A is also here. Image of B is here. So what I'm saying is that I can still have another diameter here too for this one. So that when you now join this to the center and you join this B to the center, we are going to have this. We are going to have A, B, then we have this. Okay, this is what we have. Are you with me? Are you with me? Now, so you can now see that the angular difference, this latitude that we have here, 58.4. This angle is 58.4. This angle is also 58.4. You know, I can say alternate angle, and still get this one as, I don't want to use theta, because we already have theta in the question as angular difference. Let me use beta. Because what I'm looking for here is beta. You know, I want to find the distance AB along the great circle, and I need to calculate this beta. You can say alternate angle, and still use angle on the straight line, or beta plus d is equals to 180 sum of angles in a triangle. Is that taken? Now we have beta plus 58.4 equals to what? 180. Using sum of angles in a triangle. Are you there? Now, what is the sum? 58.4 plus 58.4. 100.8 degree equals to 180. Please let me subtract that from 180. 116.8 equals to 63.2. So if that beta is 63.2, you can now say, okay, distance AB along the gray circle. Along the gray circle is going to be beta now. Although before, the formula is theta all over 360 times, but I don't want to use theta because if I use theta here, to look as if I'm still referring to this 180 as angular difference. My angular difference here, my angle here is now what? Beta. So let me now change the formula to beta over 360 times 2 pi bigger, not small again. Because we are now referring to this. This is bigger, this is what? Bigger. Am I communicating? Now, so this one now is, what is beta? 63.2 over 360 times 2 times, what is pi? 20 over 7, 6,400. Now, product of 360 times 7, 2520. What is that? 63.2 times 2 times 22 times 6,400. 1779 120. Okay? Divided by 2520. 7,062.35 kilometers. So when you now compare the two answers, this one is along the gray circle, that one is along the parallel of latitude. You can see that this one happens to be the shortest distance. 7,000 plus 10,000 plus. This is the shortest distance. Is that taken? Now write it down. Let me give you the second example where the angular difference will be less than 180. So if it is less than 180, it's not going to be easy as this. Lat 30 degree north, long 20 degree west, and B lat 30 degree north, long 40 degree east, long 40 degree east. Are two positions on the Earth surface. First off, assuming the Earth is a sphere, of radius 6,400 kilometers. Assuming the Earth is a sphere of radius 6,400 kilometers, that is bigger, comma, calculate, comma, correct to 3 significant figures. Calculate, comma, correct to 3 significant figures. A, the length of the chord AB. The length of the chord AB. The length of the chord AB. B, the shortest distance between A and B. The shortest distance between A and B. Now, let me interpret this question. Now please pay attention to this. This is the globe. Now we have this polar axis. This is equator, north, south, 0 degree east, 0 degree west, lat 30 degree north, 20 west, 20 degree west. This is point A. 30 degree north again, long 40 east. 40 degree east. You know, we are going to have B here. Unlike the first one where the angular difference is 180, and I told you that when you have that line is going to be what? A diameter. Now we have B here, we have A here. Now, this is the center of the Earth. This is the center of that latitude. You join this to this and this. Then you also join this to this and this. Okay. Now, there's no doubt about this that when you find the distance along the parallel of latitude and that of shortest distance, that the distance AB along the great circle will be the shortest one compared to that of distance along the parallel of latitude. Now, the first question there is to find the length of chord. I want to bring out the triangle because this thing. Look at this sector. This is a sector. We have this. This is a sector. We have A here. We have B here. Okay, and you can join this to this. This is a chord. AB is a chord, Abi. Then, apart from this, I can still have the diagram as this. Where this one too is a chord. Down we have AB. We have AB. You know, this one is sector AB. This is another one too. And where this one is O. This is O. Why this point here is the center of that latitude. But we still have the same chord. This is a chord. This chord here is equal to this one. Okay? Now, what is the formula for that length of chord? Length of chord AB here is equal to, what is the formula for that length of chord? 2r sin theta over 2. Please don't forget that this is R. This is R. Why this one is big R, this is big R. We have small r, big R, big R. Okay. Now, this angle here is the angular difference, Abi. And what is the angular difference here? 60. Angular difference is 60. 20 plus, Abi? Okay, in fact, I can put theta. So this is 60. Okay? But this one is beta. This one is beta. You know, I use beta there. I don't want to use theta again. Now, let us now find length of chord. 2r sine theta over 2. You know, that's the formula. Where theta is what? 60. I will now come here and write 2r sine 60 degree over 2. And where this small r is big R cos alpha. Abi? 2 big R cos alpha. This small r is this. Sine 30. Then 2 times 6,400 times cos. What is alpha? 30. And times sine what? 30. Are you there? Are you all there? Okay. So 2 times 6,400 cos 30 is what? 0.8660. Sine 30 is 0.5. Please let me multiply everything. $5,542.56. Point 4. But you said 56. 5542.4 kilometers. Okay. So that is the length of chord. Do we have degree of accuracy then? No. Okay. That is how to find length of what? So 3 significant figures. Is it 2 or 3? 3. 1, 2, 3. What's the answer? 550. 5540. Because this 2 is not up to 5. So that is how to find the length of chord. But now to find the what is the question? Shortest distance, Abi, or distance AB along the great circle. It's the same thing. When you have distance AB along the great circle or the shortest distance AB, is the same thing. Now let us now quickly do that. Now, I want to get the second question. This is A. Now, this is B. I still want to use this diagram, these two diagrams now. You know, from this one, the formula that we have here is this. 2r sin theta over 2. Okay, let me label this as diagram X and diagram Y. So length of chord AB of that x is 2r sine theta over 2. This value. Is that taken? Okay, we can still change this to 2 big R cos alpha. Are you all there? Yes. Sine theta over 2. I know that theta is the angular difference. Leave that. I want to derive the formula. You know, in some textbook, you just have the formula there. If you ask me that of the formula for getting that shortest, I don't know the formula offhand, but I can easily derive the formula, and that's what I'm trying to derive for you now. Now, so length of chord AB in that second one is 2 big R, 2R sine what? Sine what? Beta over 2. Beta is the angle here. Okay? And the two chords are the same. So I can equate the two. 2R cos alpha sine theta over 2 is now equals to 2R sine beta over 2. Are you all there? Yes, sir. Okay. 2R cancel 2R. Okay? Then, you can now cross these two. I want to do something. I want to take this arc sine to this place to give me arc sine cos alpha sine theta over 2 is equals to beta over 2. These two will now come here. 2 arc sine cos alpha sine theta over 2 is equals to beta. So this beta now is this thing. Now I already know that alpha is what from the question? 30. Why this theta is what? 16. By the time you solve this, it will give you that beta that we are looking for. So this is the formula. If you check composite textbook, you will see this formula there. But I advise you not to cram the formula. We have many formulas in mathematics, so don't trouble yourself by cramming it. But you can easily derive it. Okay? So this is the formula. Now to get that shortest, let us first get the angle. Beta now equals to 2 arc sine cos what? 30 times sine 60 over 2, abi? 60 over 2. Now 2 arc sine 0.8660 sine 30. Where sine 30 is 0.5, abi? Okay. Equals to beta. Please let me multiply 0.66 times 433. Abi? Equals to beta. Arc sine 0.433. 2 times 25.658. Then 67, abi? 67 equals to beta. 51.32. Beta equals to 51.332. Why is it 32? This is 7 now. Is it 66? 66 what?
658098889.
Okay, 66 now. Okay, if it is 66, that's multiplied by 2. What do we have? 51.332. So if angular difference is 51.32, shortest distance AB. Is that not the questions? Is that not the question? What do we have as question B? Shortest distance AB is equals to beta, not theta, beta over 360 times 2 pi bigger. Where beta is 51.32 all over 360 times 2 times 22 over 7 times 6,400. Now multiply all the numerators together. 1445 1712. 14,451,712. Abi?
Yes.
Now divide.
5,734.81.
5,781 kilometer. Do you have degree of accuracy? Yes, sir. What is that? 57330 kilometers. So that is how to find the shortest distance. That is how to find the shortest. Or even right from this one too. Right from here. Right from here. If you don't want to, okay. Right from here, I can find the length of chord of this one. Get the length of this chord of this one and equate this to this one. It's still the same thing. But we advise you to use 2R to cancel 2R of this one so that you will not be having problem of approximation. Is that taken? How many diameter do we have in a circle? Infinite number. Infinite. This is the diameter. This is a diameter. This is a diameter. 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 You cannot count. Likewise for that circle too, for a sphere. If you want to cut it into 2 equal parts, you are going to have infinite number. Infinite number. Am I communicating? So that is it. Any other question? Or do you still have any other one? Feel free to ask your question now. Stated the thing there. There is an infinite numbers of great circles on the surface of. Are you with me now? That is it. Or do you still have any other question? Now let me give you an assignment. I will give you one assignment on this, and that will be the end of latitude and longitude. So next week we are going to look at another topic. Is it circle geometry or bearing?
Bearing.
Which one do you prefer? Circle geometry. Okay, no problem. No worry. If there is time, I will still explain that of bearing too. So now assignment. Please keep quiet. X. Let me write the question. X. There is a point X. 60° north. 12° east. And Y. 60° north. 40° east. 40° east. 40° east. Sorry, 42. Change this to 42. 42° east. Our point on the Earth surface. Our point on the Earth surface. Our point on the Earth surface. Is that taken? Question A. Illustrate this information in a diagram. Illustrate this information in a diagram. Illustrate this information in a diagram. B. Taking pi to B. Taking pi equals 3.142. And radius of the Earth 6,400 kilometers, and radius of the Earth 6,400 kilometers. Come on, calculate the put colon dot dot 1. Roman figure 1. Length of chord XY. Come on, length of chord XY. Come on, correct to the nearest 10 kilometers. Correct to the nearest 10 kilometers. Roman figure 2. Angle that the chord XY. Angle that the chord XY subtend. Angle that the chord XY subtends at the center of the earth. Angle that the chord XY subtends at the center of the earth, comma, correct to 1 decimal place. Correct to 1 decimal place. What you are looking for in that question is just beta. You don't need to find the shortest distance there. Okay? Now, Roman figure 3. Roman figure 3. Distance x. Distance between x and y. Distance between x and y along their common latitude. Along their common latitude. That is what? Shorter distance. Okay, because along their latitude it's shorter distance. If it is shortest distance now, that is where you are going to use that beta. Then, and use the formula beta over 360 times 2 pi d gap. But you don't need to go ahead and find the shortest distance. What you are asked to calculate there is just beta. Am I communicating? So that is just it. Good day.
Thank you.